Hollywood loves a monster. If you watch any blockbuster war movie from the last 50 years, you will inevitably see the same terrifying sequence play out. A massive boxy gray leviathan emerges from the fog of war. Its tracks crush the earth, its long 88mm gun slowly traverses, and with a single deafening crack, it effortlessly vaporizes an American tank. This is the Panzerkampfwagen 6, universally known as the Tiger. In the popular imagination, the Tiger tank is the undisputed apex predator of the Second World War. On the other side of the screen, we are always shown the American M4 Sherman. It is depicted as a fragile, undergunned, rolling death trap. The veterans allegedly called it the Ronson, after the cigarette lighter, because its advertising slogan was that it lights the first time, every time. We are told it took 5 Shermans to kill one Tiger, and that the American tank crews were essentially sent into a meat grinder by callous generals who prioritized mass production over crew survivability. But how much of this cinematic narrative is actually grounded in historical and tactical reality? Did the American industrial machine really produce a substandard tank, or are we looking at the greatest logistical triumph in the history of armored warfare? Before we strip away the myths, break down the armor, and look at the hard tactical data, I want you to drop down into the comments and tell me which tank you would rather be sitting in when the shooting starts, the heavy German beast or the reliable American workhorse. While you are down there, make sure to hit the subscribe button, ring the notification bell, and join our community of military analysts as we dissect the realities of combat. We are going to look past the Hollywood smoke and mirrors to determine which of these machines actually won the battlefield. To understand how the Tiger and the Sherman ended up staring each other down across the muddy fields of Northern Europe, we have to rewind the clock and look at the strategic roots that grew these two vastly different machines. You cannot understand a tank just by looking at the thickness of its armor plate. A weapon system is the physical embodiment of a nation's military doctrine, its geographical realities, and its industrial capacity. Let us start with the strategic context following the First World War. When the guns fell silent in 1918, the tank had just barely crawled out of its infancy. It was a slow, mechanically unreliable siege engine designed for one specific purpose, which was to cross the trench systems of the Western Front. In the decades that followed, the United States and Germany took 2 radically different paths in their military thinking. For the United States, the 1920s and 30s were defined by the National Defense Act of 1920. This legislation essentially abolished the U.S. Tank Corps as an independent branch and subordinated all tank development to the infantry. The prevailing American doctrine was that tanks existed solely to support foot soldiers. They were supposed to be slow, lightly armed pillboxes that walked alongside the infantry to knock out machine gun nests. On top of that, the United States was protected by 2 massive oceans. The isolationist political climate meant there was no appetite for building a massive, mechanized land army. During the Great Depression, the U.S. Army was so underfunded that its total manpower was smaller than the Army of Portugal. The American military-industrial complex was practically non-existent. Germany, on the other hand, was operating under a completely different set of pressures. Stripped of their military by the Treaty of Versailles, the German High Command was forced to rethink warfare from the ground up. They were banned from having tanks entirely. But instead of accepting this, they set up secret tank testing facilities in Kazan, deep inside the Soviet Union, exploiting a geopolitical loophole. Visionary German officers like Heinz Guderian were studying the failed stalemates of World War I and writing new doctrines. Guderian published his seminal book, Achtung Panzer, in 1937, laying out the blueprint for what the world would soon call Blitzkrieg. The German doctrine demanded speed, independent armored formations, and the concept of the Schwerpunkt, or the focal point of a breakthrough. They did not want tanks tied to the walking pace of an infantryman. They wanted armored spearheads that could punch through a front line, sever communication wires, overrun artillery positions, and cause total operational paralysis. However, as the German panzer divisions evolved and began conquering Europe in 1939 and 1940, they realized they needed a specialized tool. They needed a heavy breakthrough tank, a Durchbruchswagen, to smash through heavily fortified enemy lines so the lighter, faster medium tanks could pour through the gap. This requirement eventually led to the development of the Tiger. When the Japanese attacked Pearl Harbor in December 1941, the sleeping giant of American industry was violently awakened. The United States suddenly had to fight a global war on two fronts, across two different oceans. This geographical reality is the single most important factor in the design of the M4 Sherman. The United States did not have the luxury of building a tank and simply driving it to the front line, like the Soviets or the Germans could. Every single American tank had to be built in places like Detroit or Ohio, loaded onto a train, transported to an East Coast port, lifted by a dockside crane onto a Liberty ship, sailed across the treacherous, U-boat-infested Atlantic Ocean, unloaded by another crane in Britain, and eventually shipped across the English Channel to France. This logistical chain dictated the physical dimensions of the Sherman. The tank could not weigh more than 30 tons because 30 tons was the maximum lifting capacity of the standard dockside cranes used at American and British ports. It could not be wider than 105 inches because that was the maximum width that could fit on a standard American railway flat car and pass through existing tunnels and over bridges. It had to be tall, not because the designers wanted a massive target silhouette, but because they needed to fit a massive Wright R975 Whirlwind radial aircraft engine into the hull, along with a drive shaft that ran under the turret basket to the front transmission. The Sherman was the ultimate expression of American logistical standardization. It is very similar to the logistical mastery demonstrated by General Ulysses S. Grant during the American Civil War. Grant did not defeat Robert E. Lee because the Union had a significantly better rifle. He won because he utilized the vast railroad networks and industrial capacity of the North to ensure his men were always supplied, always reinforced, and always moving. The Sherman was designed to be the armored equivalent of a Union supply train. It was reliable, mass-produced, and standardized. By contrast, let us look at the German industrial reality. The German manufacturing sector was not set up for mass assembly line production in the way Henry Ford had revolutionized Detroit. German engineering was artisanal. It was highly skilled, incredibly precise, and completely incapable of matching the volume of the Allied powers. When Adolf Hitler ordered the creation of the Tiger tank, the contract was fought over by two engineering giants, Henschel and Porsche. Ferdinand Porsche, a brilliant but eccentric engineer, designed a tank with a highly complex gasoline-electric hybrid drive system. It was decades ahead of its time, but it caught fire during testing and was a logistical nightmare. The Henschel design won, and it became the Tiger one. But the resulting machine was a 56-ton monster that completely ignored logistical realities. The Tiger was armed with the lethal 88mm 36L56 gun. This weapon was originally designed as an anti-aircraft gun, meaning it had an incredibly high muzzle velocity and a remarkably flat trajectory. It could punch a hole through the frontal armor of a Sherman from over 2,000 yards away, a distance at which the Sherman's standard 75mm gun could not even scratch the Tiger's paint. The Tiger was protected by 100mm of flat, face-hardened Krupp steel armor on its front. It was a rolling fortress. But that protection came at a crippling cost to mobility and maintenance. Let us dive deep into the suspension and track systems, because this is where wars are actually won and lost. The American Sherman utilized a vertical volute spring suspension, or VVSS. It looked like a series of self-contained bogies bolted to the side of the hull. Was it the most comfortable ride for the crew? No. Did it provide the best cross-country performance in deep mud? Not really. But here is the genius of the VVSS. If a Sherman hit a landmine and blew off a suspension unit, a recovery crew could roll up with a wrench, unbolt the damaged bogie from the outside of the hull, bolt a new one on, and have the tank back in the fight in a matter of hours. The maintenance was decentralized and external. Now look at the Tiger. The German engineers used a torsion bar suspension system with overlapping and interleaved road wheels, known as the Schachtelfahrwerk. It featured massive steel wheels that overlapped each other like scales on a fish. From a purely theoretical engineering standpoint, it was brilliant. It distributed the massive 56-ton weight of the tank evenly over the tracks, giving the Tiger a surprisingly smooth ride and allowing it to fire on the move more accurately than many contemporary tanks. But tactical reality is not a theoretical engineering test track. What happens when a Tiger is operating on the Eastern Front, rolling through the infamous Rasputitsa mud? The mud packs tightly between those overlapping wheels. When the temperature drops below freezing at night, that mud turns into solid concrete. The next morning, the tank is completely immobilized. The crew has to literally take a blowtorch to the wheels to thaw them out before they can move. Furthermore, let us ask a critical question. What happens when the innermost road wheel on a Tiger gets damaged by a Russian anti-tank rifle or a mine? To replace one inner wheel, the German mechanics had to remove up to 9 outer wheels first. It was an agonizing, multi-hour process that required heavy lifting equipment, often performed in the freezing cold while under artillery fire. It is reminiscent of modern procurement disasters, like buying a fleet of multi-million-dollar stealth fighters, but forgetting to secure a supply chain for the specialized radar-absorbent paint. You have a highly capable weapon system that spends most of its time in the maintenance bay. The Tiger was so wide that it could not fit on standard German railway cars. The combat tracks, which were 31.5 inches wide, hung over the edge of the rail cars and would smash into railway platforms and tunnel walls. Therefore, every time a Tiger unit had to be moved by train, the crew had to jack the tank up, remove the outer row of overlapping wheels, take off the heavy combat tracks, and install a narrower set of transport tracks called Verladeketten. When they arrived at their destination, they had to reverse the entire exhausting process before they could even drive to the battlefield. The German High Command, in their infinite wisdom, deployed a heavy breakthrough tank that exhausted its own crew before the first shot was even fired. While the Germans were building bespoke, artisanal, heavy tanks, the Americans were standardizing under the rigid doctrine of General Leslie J. McNair. McNair was the commander of Army Ground Forces, and he was the primary architect of the American Armored Doctrine. He firmly believed in the tank destroyer doctrine. In McNair's view, tanks were not supposed to fight other tanks. If an American armored spearhead ran into a German panzer division, the American tanks were supposed to bypass them, call in specialized, fast-moving tank destroyer battalions equipped with M10 Wolverines, and let those specialized units hunt the enemy armor. The Sherman was designed to exploit breakthroughs, destroy enemy supply lines, and support the infantry with high explosive shells. This is why the standard Sherman was equipped with the 75mm M3 gun. Modern armchair generals love to criticize the 75mm gun for its lack of armor-piercing capability against the front of a Tiger. But they are missing the fundamental reality of armored warfare. Tank-on-tank engagements were actually quite rare. Over 75% of the targets a tank crew engages in combat are soft targets. We are talking about infantry in trenches, anti-tank gun emplacements, bunkers, and unarmored supply trucks. For these targets, you need a high explosive shell, not an armor-piercing dart. The American 75mm gun fired one of the best high explosive shells of the entire war. It had a generous bursting charge that could clear out a German machine gun nest with ruthless efficiency. The Sherman was the ultimate general-purpose tool. If you compare it to the Vietnam War, the Sherman was the UH-1 Huey helicopter. It was not the most heavily armored, and it was not the fastest, but it was everywhere, it was reliable, and it got the job done day in and day out. We also have to look at the engines. The American industrial base allowed them to experiment, but they demanded reliability above all else. When aircraft engines became scarce, they pivoted. Chrysler developed the A57 multi-bank engine, which was literally 5 6-cylinder automobile engines geared together around a central shaft. It sounds like a mechanical nightmare, but it worked, and it kept the assembly lines rolling. Later, Ford introduced the GAA V8 engine, an all-aluminum, 500-horsepower beast that gave the Sherman incredible reliability and a very respectable power-to-weight ratio. The Sherman rarely broke down. If it did, American logistics ensured that spare parts were always close behind. The Tiger, however, was powered by the Maybach HL210 and later the L230 V12 engine. It generated roughly 690 horsepower. That sounds impressive until you remember it is trying to push 56 tons of Krupp steel through thick mud. The Tiger's engine was constantly overworked, prone to overheating, and notorious for catching fire. Its complex transmission, featuring 8 forward gears and 4 reverse gears, was a marvel of engineering, but it was highly fragile. If a Tiger driver was too aggressive with the clutch, or if the tank got bogged down in a ditch, the transmission would simply shatter. And because the Tiger was so heavy, you could not just tow it with a standard half-track. It took 2, sometimes 3, heavy 18-ton FAMO recovery vehicles chained together just to pull one disabled Tiger off the battlefield. If the Germans were retreating, and a Tiger broke its transmission, the crew had no choice but to pack the hull with explosives, blow up their own invincible tank, and walk back to friendly lines. By the time the Allies were preparing for the invasion of Fortress Europe in 1944, the die had been cast. The United States had churned out nearly 50,000 Shermans, filling the ranks of the American, British, and Soviet armies. They had built a logistical bridge of Liberty ships spanning the Atlantic, delivering an endless stream of fuel, ammunition, and replacement tanks to the staging grounds in England. The Germans, crippled by Allied strategic bombing and their own over-engineered designs, managed to produce just over 1,300 Tiger I tanks during the entire war. The numbers alone suggest a foregone conclusion. But warfare is not a spreadsheet, and battles are not decided by factory output alone. The strategic doctrines and the industrial realities had built these two completely different machines. The Americans built a reliable, mass-produced cavalry steed designed to flood the battlefield and overwhelm the enemy with logistical supremacy. The Germans built a heavily armored, precision-engineered sniper rifle designed to dominate a specific sector of the front line through sheer technological terror. The factories had done their jobs. The generals had written their manuals. Now it was time for the rubber block tracks to hit the European mud. The theoretical doctrines were about to collide in the brutal, claustrophobic hedgerows of Normandy, where visibility was measured in feet, not miles, and where the invincible frontal armor of a heavy tank might suddenly find itself outflanked by a swarm of 75mm guns. The strategic stage was set, but what actually happened when the hatches were battened down, the optics were dialed in, and these two legends finally met in the crosshairs. To understand how these engagements actually played out, you have to mentally climb inside the steel hull, smell the suffocating mixture of hot engine oil and cordite, and look through the periscopes. The physical ergonomics of a tank dictate how a crew fights, how they survive, and ultimately who pulls the trigger first. In the brutal mathematics of armored warfare, the tank that fires the first shot wins the engagement over 80% of the time. When you drop down into the commander's seat of an American M4 Sherman, the first thing you notice is the space. It was not a luxury sedan, but compared to other tanks of the era, it was highly ergonomic. The American engineers understood that a fatigued, cramped crew makes fatal mistakes. The Sherman commander was equipped with a fully rotating cupola featuring armored glass periscopes that provided a seamless 360-degree view of the battlefield without ever having to expose his head to sniper fire. The gunner had his own periscope, and the loader had room to rapidly muscle the heavy brass shells into the breech. More importantly, the Sherman was designed for rapid evacuation. The hatches were spring-loaded. If the tank was hit and began to burn, an American crew could pull the quick-release levers and bail out of the vehicle in under 4 seconds. Now step into the German Tiger. From the outside, it is a massive towering fortress. But inside, it was surprisingly claustrophobic. The thick armor plates and the massive breech of the 88mm gun consumed the interior volume. The Tiger commander had an excellent cupola, but the gunner and loader were practically blind to the outside world, entirely dependent on the commander to call out targets. If the tank was penetrated and caught fire, bailing out was a nightmare. The German hatches were incredibly heavy pieces of solid steel that lacked the sophisticated spring-loaded mechanisms of the American tanks. If the tank was resting on an incline, or if the crew member was wounded, pushing that heavy hatch open was nearly impossible. This brings us to one of the most pervasive and frustrating myths of the Second World War, the idea that the Sherman was a rolling death trap, famously nicknamed the Ronson, because it supposedly burst into flames upon the first hit. Why does Hollywood insist the Sherman was a death trap when the hard tactical data proves otherwise? Because a nuanced logistical victory does not sell movie tickets. Early models of the Sherman did suffer from ammunition fires because the shells were stored in the spunsons above the tracks, a vulnerable location. But the American Ordnance Department did not just shrug their shoulders. They analyzed the battlefield data and engineered a solution. They moved the ammunition to the floor of the hull and encased the storage bins in water jackets filled with a mixture of water and ethylene glycol. This was known as wet stowage. If a German armor-piercing shell penetrated the hull and hit the ammo racks, the water jackets would burst, instantly dousing the hot shrapnel and preventing the powder from cooking off. After the implementation of wet stowage, the catastrophic fire rate of the Sherman dropped to an astonishingly low 15%. It became statistically one of the safest tanks to fight in during the entire war. Meanwhile, Tiger enthusiasts conveniently ignore the fact that the Tiger stored a massive amount of its 88mm ammunition right in the upper side bunsen's. When a Tiger's side armor was breached and those massive shells detonated, the resulting explosion was so violent it would routinely pop the 11-ton turret right off the hull. The true tactical disparity between these two machines is best understood by looking at how they acquired and engaged targets. The Tiger was equipped with the Zeiss Turmziel Fernrohr 9B, an absolute masterpiece of optical engineering. It featured crystal-clear glass and selectable magnification, allowing a skilled German gunner to identify and target an enemy tank at ranges exceeding 2,000 yards. Paired with the WK-36 gun, which fired a 22-pound armor-piercing ballistic capped shell at a blistering 2,600 feet per second, the Tiger had an incredibly flat trajectory. This meant the gunner did not have to be perfectly precise with his range estimation. Simply putting the crosshairs on the target and firing was usually enough to guarantee a hit. The Tiger was the ultimate sniper. But what good is a sniper rifle if you cannot find the target in the scope? The Tiger's fatal flaw in a close-quarters brawl was its turret traverse mechanism. The hydraulic traverse was powered by a power takeoff from the Maybach engine. If the engine was idling at a low RPM, it took the Tiger a full 60 seconds to rotate its turret 360 degrees. If the engine was dead, the gunner had to use a manual hand crank, which required over 1,700 agonizing rotations to turn the turret completely around. The Sherman, by contrast, was a street fighter. It utilized an independent electric or hydraulic turret traverse system, built by companies like Oilgear and Westinghouse. Regardless of what the engine was doing, the Sherman gunner could whip that turret around a full 360 degrees in just 15 seconds. Furthermore, the Sherman was equipped with a Westinghouse gyrostabilizer for the main gun. This did not allow the tank to snipe targets while driving at 30 miles per hour, as some post-war myths suggest. What it actually did was keep the gun roughly leveled on the horizon, while the tank was moving over rough terrain. When the Sherman driver slammed on the brakes to take a shot, the gunner did not have to spend 10 seconds cranking the gun up or down to find the target. The crosshairs were already resting on the enemy. We can compare this dynamic to the gunfights of the American Wild West. You can walk into a saloon carrying the heaviest, most accurate, beautifully engraved Winchester rifle in the territory. But if the other man draws a cheap, short-barreled Colt revolver and puts a bullet in your chest before you can even raise your rifle to your shoulder, you are still dead. The Sherman was built for the quick draw, and in the claustrophobic environments of Western Europe, the quick draw was everything. Let us move away from the theoretical specifications and look at how this played out in the mud and blood of a real engagement. It is August 1944. The Allied armies are trying to break out of the Normandy bridgehead. The terrain is the infamous bocage, a patchwork grid of small farm fields surrounded by ancient, impenetrable hedgerows made of thick earth and massive oak roots. Visibility is frequently limited to less than 100 yards. A platoon of 4 American M4A3 Shermans from the 3rd Armored Division, the Spearhead Division, is advancing cautiously down a sunken dirt lane. Up ahead, guarding a vital crossroads, is a single Tiger I from a German heavy panzer battalion. The German commander has perfectly positioned his 56-ton beast. It is hull down, meaning the vulnerable lower body of the tank is hidden behind a berm of earth, exposing only the 100mm thick, face-hardened steel of the turret front. The Tiger is practically invisible, camouflaged with branches and foliage. At exactly 1400 hours, the lead Sherman creeps around a bend in the lane. The German commander spots the olive-drab silhouette. He barks a single order. The 88mm gun violently recoils. The sound is a deafening metallic crack that shatters the rural silence. At a range of just 80 yards, the kinetic energy of the German shell is absolute. The armor-piercing round strikes the frontal glacis of the lead Sherman. The 2 inches of sloped American steel offer zero resistance. The shell punches clean through the armor, vaporizes the transmission, travels through the fighting compartment, and exits the rear engine deck. The Sherman grinds to a violent halt. But here is where the reality diverges from the cinematic myth. The tank does not instantly explode into a fireball. The wet stowage does its job. The American crew, highly trained and utilizing the spring-loaded hatches, erupts from the top of the turret and bails out into the ditch in mere seconds. They are shaken, deafened, but alive. Now, the American tactical doctrine takes over. The remaining 3 Shermans do not charge mindlessly into the crosshairs of the 88 like suicidal drones. They immediately throw their tanks into reverse, backing up behind the thick hedgerow for hard cover. The American platoon leader reaches for the most lethal and technologically advanced weapon inside his tank, the SCR-508 push-button FM radio. The United States had equipped almost every single tank with crystal-clear, frequency-modulated radios, whereas the Germans often relied on static-filled AM radios, or worse, command tanks had to open their hatches and wave signal flags to communicate. The American commander instantly broadcasts the exact coordinates of the dug-in Tiger to his platoon and to the supporting infantry. How do you kill a steel leviathan when your primary weapon cannot penetrate its face? You blind it, you deafen it, and you break its legs. The American commander orders his gunners to load white phosphorus, universally known by the troops as Willie Pete. The Shermans elevate their 75mm guns and lob the chemical rounds in a high arc over the hedgerow directly at the Tiger's position. The white phosphorus shells detonate against the invincible frontal armor of the German tank. The chemical explosion cannot scratch the Krupp steel. But that is not the point. The shells burst into a massive, blinding cloud of thick white smoke that burns at over 5,000 degrees Fahrenheit. The dense, acidic smoke immediately gets sucked into the Tiger's engine air intakes and fighting compartment ventilators. The German crew is suddenly coughing violently, their eyes burning and watering. The magnificent Zeiss optics, capable of seeing a target 2,000 yards away, are now completely utterly useless, entirely whited out by the burning chemical cloud. The apex predator has been completely blinded. This tactical use of smoke and mobility is deeply reminiscent of American naval tactics during the Battle of Leyte Gulf, specifically the legendary stand of Taffy 3. When a small group of lightly armed American destroyers found themselves face to face with the massive Japanese battleship Yamato and a fleet of heavy cruisers, they did not just sit there and trade broadsides, because they would have been annihilated. They laid down massive, blinding smoke screens, used their superior speed to maneuver through the confusion, and launched devastating torpedo attacks from the flanks. The American tankers in the Bocage applied the exact same naval philosophy to armored warfare. While the Tiger is choking in the white phosphorus cloud, 2 of the Shermans crash through a weaker section of the hedgerow to the left, utilizing their superior cross-country mobility. The Tiger commander hears the roar of the Ford V8 engines through the smoke and realizes he is being flanked. Panic sets in. He screams at his driver to rev the massive Maybach engine to maximum RPM so the hydraulic turret traverse can spin faster. The engine roars, and the long barrel of the 88 slowly, agonizingly begins to swing toward the left flank. But the physics of the battlefield are unforgiving. The heavy turret simply cannot rotate fast enough. The 2 flanking Shermans break through the brush and establish a clear line of sight at a range of 300 yards. They have the angle. The Tiger's side armor is completely flat and only 80mm thick. It is a massive, unsloped barn door of a target. The American gunners step on their firing pedals. 2 75mm M61 armor-piercing projectiles cross the distance in a fraction of a second. They strike the Tiger's lower side hull just above the overlapping road wheels, penetrating the armor with ease. The hot shrapnel slices directly into the German ammunition stored in the spunsons. This time, there is no wet stowage to save the crew. The massive 88mm high-explosive shells detonate simultaneously. The resulting catastrophic explosion instantly vaporizes the interior of the tank, blowing the 11-ton turret 50 feet into the air, leaving nothing but a burning, twisted husk of German engineering smoldering in the French dirt. The ambush at the crossroads was cleared, and the American armored column pushed forward. But this localized tactical victory was just a micro-engagement in a continent that was entirely engulfed in flames. The American doctrine of combined arms, rapid communication, and high-speed flanking maneuvers had proven capable of dismantling the terrifying myth of the invincible heavy tank on a squad level. However, the sheer psychological weight of facing these German monsters took a heavy toll on the frontline crews. As the Allied armies finally broke out of the claustrophobic hedgerows of Normandy and began the long, grueling, high-speed race across the open plains of France toward the heavily fortified Siegfried Line, the tactical landscape was about to shift dramatically, and the logistical tethers of the American war machine were about to be stretched to their absolute breaking point. As the Allied armored spearheads broke out of the Normandy bocage and began their relentless pursuit across the open plains of France, the fundamental nature of the war shifted from a slow, grinding infantry brawl into a massive logistical drag race. The American M4 Sherman was suddenly in its absolute prime element. This was a tank designed for operational mobility, capable of driving 70 to 80 miles in a single day without requiring a massive overhaul. General George S. Patton's Third Army was advancing at such a blistering pace that they were literally driving right off their own operational maps. But this incredible speed introduced a terrifying new enemy that neither the frontal armor of a Tiger nor the 75mm gun of a Sherman could defeat. That enemy was friction, specifically the friction of supply lines. A single American armored division consumed an astonishing 600,000 gallons of fuel every single day. To keep the Shermans rolling toward the German border, the United States military initiated the Red Ball Express. This was a massive, non-stop convoy system utilizing nearly 6,000 2.5-ton trucks, affectionately known as the Deuce and a Half, driven primarily by tireless African-American quartermaster troops. They drove day and night, without headlights, through contested territory, creating a rolling pipeline of high-octane gasoline and high-explosive ammunition. The Sherman tank was merely the steel fist at the very end of a massive logistical arm that stretched all the way back to the oil refineries of Texas and the assembly lines of Detroit. Now, let us flip the map and look at the strategic nightmare facing the German Tiger battalions during this exact same retreat. The Tiger I was a 56-ton behemoth that achieved a fuel efficiency of roughly half a mile to the gallon on a good day. When the German army was forced to retreat across France, they could not simply load their heavy tanks onto trains, because the Allied strategic bombing campaign and the relentless ground attack missions of the P-47 Thunderbolts had utterly pulverized the French railway network. The Tigers were forced to drive under their own power. This was a death sentence for the over-engineered Maybach engines and the fragile interleaved transmissions. Hundreds of invincible German heavy tanks were not destroyed by American armor-piercing shells. They were simply abandoned by their own crews on the side of the road because they ran out of gasoline or stripped a gear in the transmission. What good is the most lethal sniper rifle in the world if you do not have the calories to carry it to the battlefield? The German High Command had built a fortress, but they forgot to build the supply lines to sustain it. We can draw a direct historical parallel here to the American Civil War, specifically General William Tecumseh Sherman's infamous March to the Sea. The Union Army did not just defeat the Confederacy by winning isolated tactical engagements on the battlefield. They won by systematically destroying the Confederate infrastructure, burning the railroads, and entirely collapsing the Southern economy. The American war machine, in 1944, applied this exact same strategy of logistical strangulation to the German armored forces. The United States did not just fight the Tiger tank in the muddy fields of Europe. They fought it by bombing the ball-bearing factories in Schweinfurt, by sinking the oil tankers in the Atlantic, and by systematically starving the German war machine of the vital resources it needed to even turn the ignition key. Furthermore, armored warfare does not happen in a vacuum. Tanks do not magically spawn on the battlefield and duel each other like medieval knights. The American Sherman operated under an invisible, impenetrable umbrella of strategic intelligence. Through the top-secret ULTRA program, Allied codebreakers at Bletchley Park were routinely intercepting and decoding the highest-level German Enigma radio transmissions. The Allied High Command often knew exactly where the German heavy panzer battalions were deploying before the German tank commanders even started their engines. This intelligence advantage completely dictated the flow of the battlefield. If an American armored column was advancing and reconnaissance reported a platoon of dug-in Tigers blocking a vital bridgehead, the American commanders rarely ordered a suicidal frontal assault. Why would they? They simply halted the Shermans, picked up the radio, and called down the wrath of God in the form of the United States Army Artillery Corps. The Americans had perfected a devastating tactic known as time on target, or TOT. Through precise mathematical calculations and synchronized stopwatches, dozens of artillery batteries located miles away would fire their 155mm long Tom howitzers at different trajectories so that every single high-explosive shell landed on the exact same target at the exact same second. A Tiger tank might have 100mm of frontal armor, but its roof armor was only 25mm thick. When a synchronized barrage of airburst artillery detonates 50 feet above a Tiger, the sheer concussive wave and the jagged steel shrapnel will instantly shatter the delicate Zeiss optics, shred the external radio antennas, snap the tracks, and completely deafen the crew inside. The Sherman did not have to kill the Tiger. It just had to find it, pin it down, and let the most sophisticated artillery network on the planet pound it into scrap metal. This level of combined arms integration is exactly why the most famous myth of the Second World War needs to be permanently buried. You have all heard the tired cliché that it took 5 Shermans to destroy 1 Tiger. This statistic is repeated in documentaries, video games, and movies as proof that the American tank was vastly inferior. But this is a fundamental misunderstanding of American military doctrine. The United States Army did not send 5 Shermans to fight a Tiger because 4 were expected to die to get the kill. They sent 5 because the standard American tank platoon consisted of exactly 5 tanks. If a U.S. armored patrol encountered a single German Volkswagen Kubelwagen, they would engage it with 5 tanks. If they encountered a machine gun nest, they engaged it with 5 tanks. Military professionals do not fight fair. They do not engage in one-on-one duels. They use overwhelming, disproportionate force to annihilate the enemy while minimizing their own casualties. Believing the 5-to-1 myth is like looking at a modern police standoff and concluding that, because it takes a 50-man SWAT team to arrest one barricaded bank robber, the bank robber must be a superior combatant. It is a ridiculous assertion born from a complete ignorance of tactical doctrine. As the war dragged into the freezing, miserable winter of 1944 and the Battle of the Bulge erupted, the American Ordnance Department was already fielding the next evolution of the Sherman. They had listened to the front crews and realized that the 75mm gun, while excellent for high explosive work, was struggling against the heavier armor of the Panther and the Tiger. The solution was the M4A3 Sherman equipped with the long-barreled 76mm M1 gun. This new weapon fired a high-velocity armor-piercing round that drastically leveled the playing field. Furthermore, American industry began supplying specialized HVAP ammunition, which stood for high-velocity armor-piercing. These rounds contained a dense, sub-caliber core of tungsten carbide. When a 76mm Sherman fired a tungsten round, it could punch a hole straight through the thickest part of a Tiger's frontal armor at combat ranges. The British took it a step further, taking American Sherman hulls and cramming their massive 17-pounder anti-tank gun into the turret, creating the legendary Sherman Firefly. The Firefly was so incredibly lethal that German tank commanders issued standing orders to their gunners to identify and destroy the long-barreled Fireflies first, before engaging the rest of the armored column. The Americans also addressed the mobility issues of the early Shermans. They introduced the horizontal volute spring suspension, or HVSS. This new suspension system, combined with significantly wider 23-inch tracks, drastically lowered the ground pressure of the tank. These upgraded models, affectionately known by the crews as the Easy 8, rode smoother, fired more accurately on the move, and could glide over the thick European mud and deep snow that would typically swallow a heavy German tank. We can see a brilliant historical comparison here between the Sherman and the legendary P-51 Mustang fighter plane. When the Mustang first entered the war, it was a good airframe, but it lacked the high-altitude performance needed to escort bombers all the way to Berlin. The Americans did not throw the design away. They adapted. They bolted a supercharged Rolls-Royce Merlin engine into the airframe, added drop tanks, and created a war-winning machine. The Sherman followed the exact same evolutionary path. It was a modular, highly adaptable platform that could be continuously upgraded to meet the shifting demands of the battlefield, whereas the German Tiger was a stagnant, over-engineered dead end that could not be easily modified without completely redesigning the entire hull and transmission. By the time the Allied armies crossed the Rhine River and pushed into the absolute heart of Germany in the spring of 1945, the debate over which tank was superior had been decisively settled by the brutal reality of total war. The Tiger tank was a terrifying tactical asset. If you placed one Tiger and one Sherman in an open field, 2,000 yards apart, and told them to duel to the death, the Tiger would win almost every single time. It had thicker armor, a bigger gun, and better optics. But wars are not decided by theoretical duels in open fields. Wars are sprawling, chaotic, logistical nightmares. They are won by the nation that can build the most reliable weapon, train the crews to operate it effectively, supply them with an endless stream of fuel and ammunition, and replace the inevitable losses without missing a beat. The German Tiger was a bespoke, artisanal sniper rifle built by a nation that was rapidly running out of bullets, fuel, and time. It was a weapon of psychological terror that ultimately failed to alter the strategic outcome of the war in any meaningful way. The American M4 Sherman, on the other hand, was the ultimate manifestation of the arsenal of democracy. It was a strategic masterpiece that enabled tactical flexibility. It was tough, incredibly reliable, ergonomically brilliant, and most importantly, it was available in overwhelming numbers. It was the tank that spearheaded the breakout at Normandy, the tank that relieved the besieged paratroopers at Bastogne, and the tank that ultimately parked in the ruins of Berlin. When we strip away the Hollywood myths, the sensationalized memoirs, and the exaggerated kill ratios, the cold, hard historical truth remains. The Tiger won a few terrifying skirmishes, but the Sherman won the entire war. Amateurs obsess over the thickness of armor plate and the muzzle velocity of a gun. But true professionals understand that victory is delivered on the back of a supply truck and secured by the relentless, grinding machinery of industrial logistics. Now it is time to turn the tactical map over to you. Based on the hard data, the logistical realities, and the strategic outcomes we have just analyzed, what is the most critical factor in armored warfare? Let me know in the comments below by choosing one of these three options. Is it A, impenetrable armor and a massive main gun? Is it B, mechanical reliability and overwhelming mass production? Or is it C, advanced communication and combined arms integration? Drop your choice and your reasoning in the comments, and I will see you on the next battlefield.